So remember, there's a charge. In Korean, is 전하. A charge is kind of electric property of matter. So, and then matter and consists of nucleus right here, and there will be consist of the protons and the neutrons, and then in here there is some electron here. Recall there is a nucleus, and nucleus is electron. So nucleus consists of the protons and neutron. Now the proton is a positive charge, and the electron is negative charge. The 1 coulomb. The coulomb is the unit of the charge. 1 coulomb is 2.6.2415. It's an electron. That means 1 electron is 1.019 coulomb. So when you say, the proton and electron extract each other, so there will be some force. And generally, there will be 1 coulomb's positive charge, and there's 1 coulomb minus charge, and the distance over here is 1 meter. Then there'll be a force between 2 charges. There's a force F is here, and C is so there will be it's a quite huge force. So anyway, there is a charge. The reason I explained the charge is to explain the current. The current is important. So what is the current? Current is a kind of a net flow of charge across any cross section of contact. What's the meaning of that? When you say we define into 1 ampere, this is a unit of current, means 1 coulomb per 1 second. It's 1 coulomb per second. What is the meaning of that? That means I don't know how much is the area about that. I don't care about that. There's a section. There's a conductor. Then the charge follow in this way, and for 1 second, the charge it passes this area. How much? You say 1 coulomb is 6.2415. It passes. then you can say 1 ampere flow through this area. So, and we need to know about the direction about current. Direction. When direction is defined, is actually and not the direction the following the electron. Actually, this is exactly opposite to the direction of electron. So actually current is a kind of a follow of the electron, but the direction of the current is defined by the current of the current. I mean, direction of current is defined not by the electron, but also not the electron, but the proton. So this is the opposite direction of the electron. And so the current amount of current will be defined by delta Q, I mean the charge, the amount of charge, and delta T is time, the charge passes through some area. So IT is a kind of the Q is the amount of the charge is derivative by the T time. So Q, the charge, the amount of charge can be calculated by the integral from the minus infinity to T, IT in this way. So we have two type of current. We can say the DC current. DC is a direct current. That means dt and dq is I is constant. AC is as we call alternating current. That means the current shape of the current is the sinusoidal, the waveform. You can say the current is AC current, like something like this waveform, right? You can express IT as K sine omega t plus phi. The K is a peak value, that value, and the omega we call this is the frequency. The sinusoidal current is very important. Maybe in this semester, the second theory is covered for 2 semesters. The first class semester, in this semester, we will deal with about the RLC circuit, electric circuit in the time domain. In second semester, in next semester, the second theory second is covered the viewpoint of not only time but also the frequency. Then the characteristic of the circuit can be analyzed based on the AC current, AC voltages. So they'll be very important when you analyze the electric circuit in the viewpoint of not only time but also frequency. So we'll cover about that in the next semester. It is very important. And this is chapter 1.3. This is a system unit. System unit is very important, and when you transfer the energy or power, is a different concept, like the mechanical energy to the electric energy, and magnetic energies, but the in the standard unit is very useful to transport the different concept of the somethings. We call it the SI is international nervous system of units. SI has a base. SI has a base unit. I mean, for example, the base unit of SI is in the case of length is a meter, and mass is a kilogram, and time the second, and the current is ampere, and temperature the Kelvin, and the SI, the prefixes. For example, we calculate the tera, define T, that means 10 power 12, and giga, say the large G, then 10 power 9 is mega. This is a large M, is 10 power 6 in kilo. Is K. The small k is right here, and milli small m is 10 minus 3, and micro is 10 minus 6, and nano m, and pico E, and femto is F. This amount is very useful. I mean, you will use of these prefixes very frequently. There are many the standard units in the SI. For example, when you say the acceleration, acceleration is very important in the mechanical systems. It is meter per second square, and the velocity will be meter per second, right? And maybe force will be a Newton. There will be the same thing with kilogram meter per second square. And what is the energy? Energy is a joule. That is the same with Newton meter. And what's power? Power is a kind of the definition of power we'll explain in the later, is the derivative the energy by time. So the power is generally joule per second. And the electric charge is Coulomb is ampere second, because what is the current? Current is defined Q, T. Q is Coulomb, this is ampere, this is a second. So C is ampere second. So that is this unit. And the electric potential there will be voltage. Volt is, this is watt. This is the another unit of the power. There will be watt. Watt divided by the current. And electric, the resistance is ohm is voltage divided by ampere. And this is a very useful units. We will start about that. This unit is very important and very useful. When you check the answer is right or wrong, then you can check your unit. Physically, the units, unit should be physically the equal between two quantities. Then, okay, we'll study about the 1.4 is the voltage. So in the same word is electric potential. In Korean, this is with Ch01. Maybe we will learn the magnetins in Korean is 전자기학. Then we will study about the physical meaning of electric potential. But the electric circuit, I don't care about exactly the field. In the circuit theory, is a very simple approach to analyze the electric circuit is the point of the lumped parameters. So in the point of electric circuit, you don't care about what is the electric potential field, because the electric potential is kind of the field. But we just simply think about the potential that is a kind of some values between 2 points. Actually, so the point of that, the voltage is a definition is like that. The voltage is a definition is voltage occurs an element is the work or energy required to move a unit positive charge from minus terminal to plus terminal. And what is that? I don't know what is that, but anyway, some element is here. And we define this point A is a minus terminal, and define that this terminal is plus terminal. Then we insert here some positive charge here. Then we move this positive charge from here to there. To do that, we insert some energy. There will be the potential of that. That is, so the V is W dq. So I will give you more simple explanation about that. The voltage is a potential difference in Korean in 전 위 차. When you say maybe you insert the positive charge here, 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 maybe 1, 2, 3, 4, 5, 6, 7. And we adding negative charge here. 1, 2, 3, 4, 5, 6, 7. The number should be same because actually this positive charge and negative charge is the same. I mean, it is from the same things. So the plus charge extract the minus charge, and minus charge extract the plus charge. Oops, sorry. Plus charge extract minus charge, and minus charge extract the plus charge. There will be some force. There will be some force. So, but what is that? But some barrier divide the charge, the positive charge and negative charge. So, because of that, here, and its point, this is a minus terminal and this is a plus terminal. And you say, because this is a positive charges, positive charge extract the negative charge from here. In other words, the positive charge push the same positive charge here. So if we adding the positive charge in here, then there could be this positive charge has a force in these directions. So if we want this positive charge to move from the minus terminal to the plus terminal, then this positive charge should push up by force. And this distance is D. Then this positive charge has the force F. Then to move this positive charge to here, then the positive charge should has some energy from this point X1, H1. This point is H2 to F, and distance D. So D, H. So this is kind of energy. So it's a joule. So we define this energy for the one charge, from here to there. Define that is a potential difference. So 1 volt means 1 joule divided by 1 coulomb. So potential difference is energy converted by the charge. For example, I'll give you some simple example. Here, I don't know what is that, but some element in this way here, and here, and here, and here. You can say this point is A, this point is B, and this point is C, and this point is D. And we'll define the voltage difference between here and B is we call Vy, and we'll say this is Vx, and this is Vz, and this is I don't know, this is 2 volts, and here is 3 volts. And then you say, in the same terminals, Vx is from here to there, and Vy is from here to here. But these are the same things. So in other way, Vy will be same with Vx in the minus, because the same voltage difference will happen, but the terminals, the direction is different. So we can say the Vy is a minus Vx. And VJ, you need to say the VJ. What is a VJ? VJ is a voltage difference, potential difference from A to D. The way from A to D is there are two ways. For example, we can go through from A to D through only that way. Another way is go through the here and here and here. The same things. So we can write the VG is amount of that. What is that? Vy and amount that. What is that? This is opposition of that. So minus 3. And this way is from here to here is a plus 2. So we can say Vz is Vy minus 1. So if VAB is 4 volts and VAD is 5 volts, the what is meaning of that? VAB is 4 volt means we defined VAB will defined is from B to A. So there will be Vx. This is minus Vy. We can say, we can say VAB. This is from. This is a 2. So we can say when you say VAB means that is a VAB. So Vy is minus 4. So then you can say the Vg is 4 is minus 5 volts. You can say in this way. Okay. So because the voltage is a potential difference, so when you define the voltage difference in this way, it's the same in the past to do this way. Then we will talk about the power. What is the power? What is the power in the electricity? The power is the rate of energy conversion. So the unit of power is watt. Can we read this watt? Watt is the same thing with energy per second. And we define the direction of power in this way. So because power is this is work. This is not watt. This is a work. I mean it's energy. D work dt. So d w work. This is work in dq di. So this is, what is that? This is a voltage. And this is, what is that? This is current. So in the viewpoint of the electric circuit, the electric power is voltage and current. And we say the direction of the power is important. I mean, in some case, power is received, or in some case, power is supplied. Okay. There is some element. What is that? I don't know what is that. Whatever it is, this is some element here. And we define here is a voltage in this way. Then we define the direction of current is in this way here, I. Then the power is P, is V, I is toward this element. And you say this element received power. You say it like that. And in the other way, there's some element. What is that? I don't know what is that. But we define this V here. And the current is in this way. And power is also I. Then in the case of that, this element supply the power. That's important. So this is quite confusing, but it's very simple, and you need to know about exactly. I will give some example here. There'll be some DC source is a kind of a battery. There'll be with 10 volt here. Then there will register. This is R. Is 10 ohm. Then maybe you will learn in this like a theory, simple theory based on the Ohm's law. But anyway, we define the current in this way. I is 1 ampere here. Define the current in this way. Then, in the viewpoint of the here, what happened? This way, current is flow from this point. So the power is 10 volts and multiplied by 1 ampere is 10 watt. Then we say the current from the positive terminal to the negative terminal. Then the battery supply 10 watt. But in the point of that, because the current 1 ampere current flow through this resistor, there will be voltage 10 volt and current of 1 ampere. The power is 10 volts and 1 ampere is the same power, right? But in this case, this is the battery, this is a resistor. In this case, the current, the flow through these positive terminals. And you can say this amount is received, and this is supplied. Why? Because current flow from the positive terminal. But we can define the current in the different ways. Then if you say the current direction of the battery is that way, we define the I and we define the voltage here in the battery. Then what is the power of the battery? What is power of the battery? Is P will be VI, right? Then what is the V? V is 10 volts. And what is current? We define the current positive direction of that is this way, but current flow this way. So in this case, current will be -1 ampere. So what is that? It's minus 1 watt. We define the current distribution of this way. So that means this battery is minus 10 watt is received. What's the meaning of this sentence? Minus 10 watt is received is the same way, same word, same meaning. 10 watt is supply. So you don't confuse the direction of the current. So generally, we define the current direction is defined as if the element is source, it's like that, then we define the current direction in this way. And in the element is a passive element like R and L and C, then we decide the current direction of in this way. So we call this is a passive convention. You can say there is active convention. And generally, we use the passive convention in the RLC. In the case of source, we use the active convention this way. So this is a couple of things we discuss in the sections. So I will give you some example about that. The example 1.51. We define here is something like here. I don't know what is the element, but define the voltage is in this way. And you find the current direction is I here. Then when you say the V is 8 volt and I is 25 milliamperes, then find the power and energy during 10 milliseconds. Can solve this problem. The solutions. What's the power? Power is voltage and current. So this is 8 volts and current is 0.825 amps. So it will be 0.2 watt. Then because current through these positive values, so this element received the 0.2 watt. And this is energy. Energy will be written in W is work because this is a work. Is 0.T P dt because the P is the rate of the work. So the work is integral of the P. So in the problem, the time is limited is 10 milliseconds, 0 to 0.01. The P is 0.2 dt. Will be 0.002. The unit of that is joule. So in other words, 2 millijoule. Then right here. And this is another example. Your example is 1.54. So now, and then I don't know what is that. The lightning, the thunderbolts, the kind of something, whatever it is something here. We will say. I mean, this problem said there's a lightning, the thunderbolts. The current is 2 10 power 4 amps. So huge current. And typically the voltage is 5 volts. But typically the thunderbolt, the typical duration is time is 0.1 second. It's very short times. So determine the total charge by the thunderbolt. There's a problem. So M, the energy, you can say the problem simply because what is a Q? What is the total charge? Charge Q is a kind of current, interval of current, 0.01. Why? Because definition of current is the rate of the charge in some area. So in this case, 0.1 to 10 power 4 T is the unit of that is coulomb because the unit of the charge is coulomb. Then what is the energy? Energy is W. This is work. Is 0.1 V I D T. 0.01 is 2, 10 4, 5, 10 power 8. Okay, maybe will be. That means 1 terajoule. It can be simply written in this way. This is example of chapter 1. So first example is exercise 1.1. So we have four elements here. The problem one element. This is a 4 volt and this is a 3 ampere current flowing in this manner. So we need to calculate the power. So we have some device element right here, and we define the polarity of the voltage. We define this as V, and we need to define the direction of current flowing to this element. And generally, we define the positive direction of the current is going into the positive direction of the voltage. Then we decide to the direction of current is in this manner in here. Then the constant of power in this element is calculated by voltage multiply current. Then if the P is V and I, then P is positive. That means P is consumed. If P is negative, that means P is generated. So this is example of battery here. We have battery. This is 5 volts. If current is going out from this battery, maybe into 1, 2 ampere in this manner. The in the viewpoint of this, if this is element's battery, and we will represent this situation is like that. This is about 5 volts, and I define the current is because I decide this direction is positive, but in the case the current going out to the battery. So if we represent this current, minus 2 ampere. Why? We decide the positive direction of current in this manner. But the current going out from the battery, so then we can represent the value of the current is minus 2 ampere. Then power can be calculated. P is V and I. Then V is 5, then current is minus 2. So therefore, there's minus 10. So this is negative values. So you say P is negative, that means this amount of power, 10 watt, is generated from this battery. If this battery here and 5 volt here, and this is charging, that means 2 ampere going into the battery. Then call this is a discharging. In Korean is 방전, and charging, and 충전. So we will represent this situation in the same manner. This element has 5 volt and current, the direction is in this manner. Then the current is 2 ampere. Therefore, the power is VI is 5 and 2 is 10. Because 10 is a positive values. So this power is consumed. That means 10 watt is consumed in this the element. Because this is a battery, not a resistor, the 10 watt is stored, is charging in the battery. So we need to understand in the direction, in the sign of the power. The power is positive when you define the current, the direction in this manner. It's like that. The current going into the positive voltages. Then the power is calculated based on that. The power is positive, that means the power is consumed or stored in this device. With the negative values of power, then that means the power is come out from this device. Because we decide the direction of current is going into the positive direction of the voltage. So this example here, then 3 ampere going into the positives. So the power is 4 and current 3 and 12 watt. 12 watt is observed. So other case, so a device here, and this is minus, plus, and 2 volts, and current going into in this direction is 6 ampere. Then in this case, we define the direction is in this manner here. Then it is minus 6 ampere. If define the direction of the current is like that, because 6 ampere move in this manner, that means minus 6 ampere move in this manner. Then power is VI, and the direction of the current is going into the positive values. So there is 2 and minus 6. There will be minus 12 watt. Then P is negative values. That means 12 watt is generated or supply. In other case, here, this is a 6 volt, and plus and minus, and current going into in this manner. So the direction is current is going out from the positive voltages. So we don't like that. So we choose in this manner current. That means this is minus 2 ampere. So power is V and I. V is a 6 and current is minus 2. So therefore is minus 12 watt. What's the meaning of that? Because this is negative values, so 12 watt is supplied. The last thing is like that. We define the direction of the voltage is 3 volts and current going to 4 ampere going into the positive direction of the voltage. Then P, power is V and I. Then because this direction is going into the positive, so that did we choose. So 3 and 4 is 12. Because that value is positive values, therefore 12 watt is observed by this device. So this is very important to get the power is positive or negative, then power is observed or supplied. We have another problem, to example here. So this problem is 1.5 and 4. So we have two figures. I don't know why it's that. Anyway, we have some element here. And we have the device. There is a voltage here. It's a V. And we have the current. The current figures this manner. So current, the going out from the positive values is current I in this manner. Then the figure of that is like that. There's a voltage. Is current. And this is 10 second. This is second. And second, we have on 10, and here is 15, and it's 25 second. And here, then the voltage is a V volts. We have 3 volts, and go down to the 5 volt in this manner here, and stay state 5 volts. The current is, the unit is ampere, and to the 15 second, the going up the current this manner, this is 30 amperes. And it go down is 0 to 25 seconds. So we need to calculate the power based on the this case. We have long because we said this is a passive convention. We have the passive convention. So the duration is in this minute here. So we need to know the total energy delivered to the element. The problem is, what is the total energy delivered to the element? So it's quite simple because there are three areas here that we need to calculate the power. What is power? The power is V and I. The V can be represented here. This is 30 values when t is smaller than 10 seconds. Then we need to calculate this, the graph. So this is a V, t here is the minus 5 and t, and plus 8. This is a waveform of that. So minus 5t and plus 8 from 10 to 15 seconds. And after that, the voltage is 5, where t is the larger than the 25, the 15. Seconds. The same way, we can calculate the current. Current is more simple with the 2 steps. So there will be 2t for t is more than 15. Then minus 3t plus 75 when t is larger than 15. That's the waveform for that. And from here, we can calculate the power. The power when t is from 0 to 10, V is 30, and current is 2t, so there will be 60t. Then from 10 to 15, then voltage is minus 5t plus 80, then current is still 2t, so there will be minus 10t square plus 160t. So we rewrite here is minus 10t plus 10t square plus 160t. Then after t is larger than 15, then the voltage is 5 and current is minus 3t plus 75. So it'll be minus 15t plus 375 volts. So we have the three things here. So we can draw the power. In this manner, this is a 10, 15, and 25. So it'll go up to the here. That'll be, this is a 600 watt. And after that, it'll go up to the 10 second. So here is like that. And at the second time is 15 second. Then that will be here is minus 10 and 15 square plus 160 and 15. There will be 150. So here that will be maybe 150 watt. So it looks like in this manner here. Then after that, they'll be go down. They'll be go down to 25 second. There'll be zeros. So here is go like that. So there'll be a power. Then if you want to calculate the power that will be observed, because the duration is the passive conventions like that. The P is positive values, so they'll be observed that this power is observed in this device. And so once more, if you want to calculate the energy from the power, then what is energy? Energy integral to minus infinity to t, the p, tau, d tau. So we have assumed that before the 0 second there are no powers. Then in this case we can rewrite the integral. The period is from the 0 to t, p tau, d tau. Then what is the energy here? It can be from 0 to t is 60t, tau d tau. So there will be three t square when t is from the 0 to 10. Then after that, what happens? Then the 10 to t, there will be minus 10t square plus 160t. Here comes with this tau, it's d tau. So there will be then plus, and e t is 10. So there will be minus 5, and then I'm sorry, this is 10t third plus 80t square, and the e, I'm sorry, we have to change the station here. Minus 10 t, oh no, ten over 3 t minus 10 square, no, the third plus 80 t minus 10 square plus e t equal 10. So this is a manner. And after 15 to t, there will be minus 15 tau plus 375 to tau plus et equal 15. So that will be minus 215 t minus 15 squared plus 375 t minus 15 plus e t will be that values here. So from here we can draw the power and the energy in this manner here. So we go energy, the unit of that is joule, then it'll be increase 10 seconds, 15 and 25, maybe it'll be increase in this manner, and it could be this like that, and it looks like here 10, 15, 25. So this amount energy will be observed by this element for 25 seconds from the figures, given figures. So you know that if you choose the passive conditions, that means this element, we define the voltage direction here, then current direction is going into the positive the voltages. We call this is a passive convention. Then the power is in VI. If P is positive, then the power is observed by element. Or P is negative, then P is supplied by element. And if we define the direction of current in this manner, this is V, and the direction of current is defined in this manner, we call this is active convention. Then power is same thing, V and I. Then P is positive, that means P is supplied by element. And then P is negative, then P is observed by element. So when you define the power in the circuit, you need to check the exact direction of the current. That's very important.